Ho, ho, ho. If it isn't Gary the Goo Boy again. Hold on. Hold on. We're not playing League of Legends. It says that every time. Why? Game dev. Oh, gosh. Development. Okay. There we go. Beautiful. Let's go back to my channel. Now I can see chat. Oh my gosh. Wow, it must be nice to be back with Gary, huh? Huh? I think it's kind of cool. I think it's great to see Gary back, even if I'm kind of crooked right now. I am kind of crooked. I'm a little bit crooked. It's my iPad's way over here now. It's a temporary fix until we get everything set up. I just wanted to get Gary back, you know, for old time's sake. You can tell there's a little bit of an issue with like blinking and stuff. Delete. Copy, paste, enter, send. Beautiful. Okay, Gary is back. Wow-wee, it's been a while, huh? Huh? Let me just get some music kicked up here. Oh, do we play some lo-fi Leah? The tracking isn't good right now. Oh my God. Not Fauna is playing Crusader Kings 3. That's pretty sweet. Let's turn on some Hololive music, I feel like. Playlists? Playlists, please. Playlists! There. How we doing? That's a cover, but we'll skip it. The rest is fine. All right, sweet. There we go. Okay. We're back in action. Hi, I'm Gary the Goo Boy. It's gonna be a little bit weird in terms of like getting me set up because I'm looking at the screen, but when I look over here, there's the iPad that's like straight, and then over here is somewhere I'll never look. So I don't know how we're gonna get this settled. Maybe I can move it like here. There, now I'm looking at the camera here, then over here. Yeah, okay, I could see it. Hold on, I'm almost there. Hold on, I'm almost there. Twitch, Gary. Okay, there we go. All right, now I can see everyone. Hi. Hello, I'm Gary the Goo Boy. And we're back. Oh boy, we got a lot to do here. Hold on. Okay, so real quick, let me just see something real quick. I kind of just want to buy. Whoop. Okay, there we go. Now you don't see anything. I kind of just want to log out. Nah, whatever. We'll come back later. I'm gonna buy a few things to set this up because I need something to hold the iPad now because I have a stand here, but it's like blocking my screen right now. It's kind of hard to explain, I guess, without showing a full camera, but it's like blocking the screen in order to get like the full range of motion. It's a little bit weird. It feels weird to be a VTuber right now, you know? Hold on. How's the mouse tracking anyway? Okay, we got a mouse button. Now let me see. Do I have my old model? I do. You know what? Oh, hi, chicken arms. There we go. Now we're going. Now we're going old school. Now we're old school. Hold on, wait. Does this still do this? Wow! Whoa! Whoa! Classic. All right, let me actually scoot in. There we go. Oh my goodness. Hi. Why are my eyes like drowsy? That's kind of weird. Welcome. Wow, this is an old model. Just looking at this model, it's like, man, this thing. This is a little, man, this model. Why are you using your old model? It does look weird, doesn't it? don't know. I'm kind of torn. The old model is, how do I say this? Whoops. Oh, too fast, too fast. It's a little bit too sensitive. Hold on, I'm gonna scoot very far away from the camera here. Okay, that's the farthest it goes, huh? Okay. All right. I could toil. Hi. Huh. There we go. I think we can use my old model. Let me just. Okay. Motomodachi. Let's skip this song. So, let me scoot down here. There. Now let me move my camera back. Okay, how's the sensitivity now? Not bad. Blinking is linked. I don't think the old model's bad. It's just, it's so not emotive. I can do this. Oh, see? I can't even bang my head correctly. All right. What were we doing? Oh, yeah, we were programming. Okay. Oh, my computer. Oh, shit. Okay, hold on. I forgot. I was like, why is my keyboard, like, not moving correctly? Okay, I forgot I had to plug in, like, a Wi-Fi thing on my computer for my iPad to connect to it. The newer model feels more realistic. We can use shaders in SDL3 now. Oh, Owl Mickey, you don't even know. Here, let me bring out Paint for you. You guys want to know how good SDL3 is? Okay, let me blow your mind. Okay, so before what you would do is you would have SDL2 and you would have a window, right? And this would handle maybe input and the window. And that's kind of the basic of SDL2. And then in that window, you would run something like OpenGL or like Vulkan. And all of it was fine and it's all dandy. But SDL3 does something a little bit different and it's actually really cool. SDL3 does something cool. SDL3 is an abstraction layer or provides an abstraction layer for 3D rendering. So now you have your window and your input and the, oh God, not library. What do you call it? API. And it gives you the API. So now it's stuff like SDL GPU. And in that like branch of SDL GPU, that actually gives you an abstraction layer where it can run any API under it. It can be Metal, it can be OpenGL, it can be Vulkan, it doesn't matter. You can give it a quote unquote hint. You can actually provide it a like a recommendation for the kind of thing you want rendered, but you can actually set it to default, meaning whatever the person's computer prefers, you can run that API. It doesn't matter. As long as we give it the shader language that's like compiled in binary or whatever you call it. Yeah. So that's what we're gonna do. We're gonna run SDL GPU, and in that, it'll run Metal, it'll run OpenGL, it doesn't matter. Shader language is compiled into binary, so that's gonna be fun. You can still use OpenGL and Vulkan with SDL3 if you wish. True, but why not use the feature that's available, you know? Let it use OpenGL. We're just concerned with the abstraction layer. So we're gonna have to do things like set up like a render pipeline. We're gonna have to like set up the shaders. We still need shader language and all that good stuff, but we're not gonna use OpenGL vectors. We're not gonna have like Vulkan down to the Metal fucking functions, you know? We're gonna call SDL3 and it will handle all of that, right? SDL3 does great things. But that's what we're gonna do today. We're gonna set this all up because boy oh boy, it can be a bit of a headache. Vulkan is also cross-platform. Yeah, but SDL3 can run Metal, so Apple will be easier. OpenGL sucks. I'm just learning the basics of graphics with OpenGL right now, and I want to switch to Vulkan. Or maybe STL3 if it's good. Well, we're gonna do it today, so that'll be fun. Okay, so ignore this for a second. We're gonna come back to that. Let's look at... Also, how's the volume? Pretty low, beautiful. Okay, so let's look at something together. Let's look at STL3 GPU. So this is pretty beautiful. STL3, if you guys don't know, has much better documentation than STL2 did. So what is an STL3 GPU? The GPU API offers a cross-platform way for applications to talk to modern graphics hardware. It offers both 3D graphics and compute support in the style of Metal, Vulkan, and DirectX 12. A basic workflow might be something like this. This is what we're gonna do for our project, so we are gonna read this entire thing. I'm sorry if this is a little bit boring and stale, but we're gonna be applying this to a real project that will have real people using it. It is going to be a Hololive fan game, Holorhythms, so, you know, it is gonna have real customers. So it is important we read this correctly. I've already read it, but still. Okay. The application creates a GPU device with STL create GPU device. Okay, so what does that mean? That means when it says GPU device, it's not literally saying your 4090. What it's saying is that a device, oh gosh. I'm trying to explain this simply, and the fact that I have trouble now means I probably don't understand it enough. As I understand it, a GPU device is just, it's kind of like a class object, but not really a struct, where it just contains data. And this data gets shoved into your GPU whenever you need it to do a thing. That's what it means by device. So it's not literally you're tossing your 4090 information into the function. It's more like a struct. It's like a communication thing. I heard the error handling is much better, so I hear. And assigns it to a window with claim window for GPU device, although strictly speaking, you can render off screen entirely, perhaps for image processing, or not use a window at all. So claim window for GPU device, all this does now, oh gosh, I forget the term. It sets up, oh God, I forgot the phrase. Hold on, I've read it earlier. Swap chain, that's what it does. So it sets up for swap chain kind of, gosh, do I need to explain what swap is? Basically, when you render a frame, there's two different frames going on. You have your, I don't know why I'm looking over here, like the camera, I should be looking over here where you guys can like, or I'm actually looking at you, sorry. The GPU, oh gosh, swap chain. So when you have a frame that you're building on the screen, because the game runs at 60 or 120 frames a second, whatever it is, right? So you have your frame that's being presented to you, and then under it, the next frame is being processed for display, right? You take an input, you compute logic based on the input, you render out the graphics, and then at the very last step, you present the frame, right? So it's render, present, but you're not doing this on one frame. You're actually building the next frame and presenting the other, and then swapping between the two every frame. So it's present while you're building it, and then you swap it, present the new one, and then you're building off the old one again. So that's, as I understand it, swap chain. That's what this function sets up here. Although strictly speaking, you can render off screen entirely, perhaps for image processing. We are not going to worry about that. We are going to claim the window. It's a video game. Although it would be interesting to test out. I wonder if it'd be easier to test all this without any window at all, but whatever. Next, the app prepares static data, things that are created once and used over and over. For example, shaders, programs that run on the GPU, use STL create GPU shader. Now, as I understand it, we're not actually going to be making that many shaders. We're probably just gonna have one shader that handles all of the notes on screen, which is like circular notes. And then we're gonna have another shader for the video that's playing, although that might just end up being That might just end up being thousands of textures that are just rendered onto the GPU, but I don't know yet. I don't know if that's gonna end up being a shader. It's probably gonna end up being a shader, right? The video in the background, and then maybe a third shader for the hit point bar, the music bar. It's a rhythm game. You miss notes, you lose bar, right? Maybe another shader for that, but if nothing else, we'll have at minimum 3 shaders, which is fine. They're actually gonna be pretty easy too. It's not like shader language is that difficult. I mean, we've already played around with it. There's a great website called, is it Book of Shaders? Is that what it is? That's not it. What's that called? Book of Shaders. The Book of Shaders, that's right. So this is your like basic bitch. Here's how you do a thing. So it'll teach you how to do cellular noise. So like, there, see? I don't know how well you guys can see this. You guys want to see something cool? So the Book of Shaders can teach you how to do stuff like this. This is just a shader. That's all this is. Which is pretty cool, right? And then in real time, you can actually mess with the parameters and all that. Oh, I love it. What a great website. And then if you guys want to see this in another way, they actually say, show ISO lines. Here we go. There you go. So that's what this looks like without ISO lines, which is pretty cool, right? So that's the power of shaders. And this whole website's just fantastic. I love Book of Shaders. Oh, that's so creepy. Yeah, and you can do art and all that, and it teaches you how to do cool color stuff. We're definitely going to be using some of this, but I'm already reading through this on my own. I just really like this website. Man, it's so fucking creepy. And then it gives you like little homework assignments, like, hold on, this is the noise one. There you go. It teaches you like, here's how you like, draw this. And it teaches you how to do the lava lamp effect. And it's like, whoa. I don't know. There's a lot of cool stuff on this. Like it teaches you how to do motions. So, oh, skew it and then subdivide. Yeah. There was one here that did motion. Here. So it was add some noise, use the noise function, smooth. Oh, maybe not. Well, in any case, that's Book of Shaders. Vertex buffers, array of geometry data and other data rendering will need, use SDL upload to GPU buffer. So this is different than OpenGL. In terms of ease of use, I happen to know a little bit of OpenGL. Building a triangle is so... It's like, it's a learning, it's not a learning cliff, it's a learning like fucking brick wall. It is the amount of shit you have to know before you get your first triangle, and then it smooths out. Upload to GPU buffer is just like 5 steps in OpenGL. All you do, it's just a function that you give a bunch of geometric data to, like any vertexes, like how many, like number information, but you also have stuff like color. I think there's a bunch of parameters here. Hold on. Yeah. Copy pass handle, source transfer buffer with offset, destination buffer with offset and size, cycles the buffer, otherwise overwrites. Super. Oh, I love SDL3 documentation. Then we have textures like images, use SDL, upload to GPU texture. We're probably going to use this most often, given that we are a rhythm game. Like here, we're going to use this exact thing, right? So this is one of the videos in 180p that we're actually playing in the background, higher resolution. But like, this is the kind of stuff that the GPU is going to have in the background. And what's probably going to happen is that every frame will have a texture of the video. We're going to have to like not decompile, decode. Is that the right word? We're going to have to decode the video and give every individual frame on like an array or something. And I think that's how we have to do this. Anyway, that's going to be something we do a lot of. Space Cadet Aphrodite, welcome to the, we're building a rhythm game about Hololive music because I want to. Gary, where's the card game? Hey, we're learning new stuff, okay? I had a lot going on in my life. I'm building a project. God, you guys are gonna love this video game history project so much. I know I talk about it. I know, okay? I am looking at the set right now. It's beautiful. It's wonderful. You guys are gonna love this video game history project, okay? I promise you, when it comes out, I'm gonna cash in on every single like connection I have in VTubing. Like there are gonna be people I haven't collabed with in like 4 years. 3 years? I haven't even been streaming for 4 years. 3 years that I'm gonna message and be like, hey, I don't know if you remember me, but I like your impression voice of me. Aphrodite. That wasn't you specifically. That was you as like that's what my audience sounds like to me in my head. Because like half my audience are women, I know that. And then the other half are like programmers and video game players who don't watch any other VTuber. I have learned this, okay? I have learned this about my audience. Okay, samplers, how textures should be read from. We'll learn that later. Render pipeline, a pre-calculated rendering state. Okay, this is extremely important. The graphics pipeline, the render pipeline is gonna be pretty phenomenal for our use case because we are making a rhythm game where every level is going to have the same setup. All we have to do is just plug in the numbers and go. So it's just a simple loading screen. Chat, hear me out, okay? The loading screen for this, like palette for Toa, right? So palette, while like the loading screen is going on, I was thinking of like pulling up like YouTube comments like that are really nice or something and just have that like appear as like the game's loading. I don't know, that'd be kind of cool, right? And Toa gets her palette song and all that. Oops. What a great song. Palette is an excellent song. Paletto. I watch other VTubers. You don't count, Cooley. You've been watching me for literally as long as I've been streaming, okay? You've had time to expand your horizons. How am I tracking, by the way, when I look way over here? Hold on, I have to... How do I look when I'm over here? It looks like I'm high. I need to remember to face... Okay, I'm looking at the set, looking at the camera, looking at the computer, looking where I used to look directly into the camera. So forgive me for doing this. I'm still getting an arm for the iPad, okay? Until then, you gotta deal with Sideways Gary for a bit. This is my song by Watame. Does Twitch tell you your demographics? It's a combination of YouTube audience information because people sometimes watch the YouTube stream and I used to make YouTube videos. And it's a experience because I know a lot of the people who watch me repeatedly. 0 women here. Oh, wow, Mikey. Don't accidentally click Aphrodite's user profile to see if her streaming life. Render pipelines. Basically, instead of recreating a scene of shaders and vertex buffers and all that, as I understand it, a render pipeline is just, you've already calculated it all once and you're just referencing it again and displaying it again. It's a very efficient way of displaying shaders. The difference, I think, between a program with a pipeline and without a pipeline, do you guys remember those old PlayStation 1 games where you would rotate the character around and the game would lag until you stand still and then it would kind of catch up with you? I think if they used a pipeline... No, that's too broad. That's not a good example, right? This is why I think I'm not good. This is why I try to explain it something to you guys, because if I can't explain it, I feel like I really don't know it. So I shouldn't be overconfident here. Shows up, screams, falls asleep because I've got home from work. Seismic! Oh my goodness, all the old school people are here. What the heck? Don't redeem Actually, no, you can redeem Femboy. Hold on, do I still have my preloads? I don't have my hotkeys anymore. B, Femboy. Femboy was saved. Oh, no, I wanted to load it. What the fuck? Hold on. Can I not load my item sets? I don't know how to do it. I don't have my my thing now. I guess I could put on a bow. What the fuck? Why do I have this? The hell? I need to clean out my folder. What the heck? Hold on, I have a bow. I can put on the bow. I'm okay with that. There you go, chat. You get Femboy Gary. You get it for today. Be spoiled, all right? The Stoverty made and shit. Okay, I don't have anything else set up. All right. To render, the application creates one or more command buffers. If you're wondering, by the way, why we're doing this all in like a 3D, why we're making like a 3D engine for what is ostensibly a 2D rhythm game. One, the difference between a game with shaders and without shaders is shocking amount of quality. I feel like games with shaders always look so cool compared to like games without shaders. And two, it solves our problem with music videos, because if we want this music video playing in the background, for example, you know what? You guys get a 1080p video for a bit. If we want like what the fuck? Marine. Oh my God, Marine. Okay, not this video. What the fuck, Marine? Here, we'll get Mume playing. So if we want like this playing in the background, which we do during the rhythm game, we're gonna need a rendering API for like 3D rendering like OpenGL. And in that case, we might as well use SDL3 because that's what it just implemented a few months ago. I love this song. Sorry, now I'm watching the music video. You guys don't even hear it, do you? You guys really don't hear that song at all. God damn, I kept that shit quiet. Oh, Marine's new song is catchy. Aphrodite, you know Marine. That's right. Oh man, it's so weird to me that Aphrodite knows Hololive now. Oh, this is like worlds colliding. That's why I didn't like making games with just SDL2 before. Yep, that limitation. I agree, no shaders is ugly. It's not that it's ugly. Like Super Mario World isn't ugly. I think Super Mario World is a great looking game. I just think that a game like, what's like a good example of like a 2D game with shaders? Like Binding of Isaac, I think looks better than Super Mario World. Just my opinion. I don't think Super Mario World is ugly. I just like the look of shaders more than not shaders. Rendering can happen to a texture, or what other APIs call a render target, or it can happen to the swap chain texture. It's just a special texture that represents the window's contents. The app can use wait and acquire GPU swap chain texture to render the window. Render actually happens at a render pass, which is encoded into the command buffer. One can encode multiple render passes. Oh, I've heard about that. Where there's, what's it called? Like a double pass or a triple pass or whatever. I wonder, well, I mean, we're obviously not gonna need it. We're not doing like a AAA game or something. I wonder when you would use like multiple passes for a single frame. Maybe, I'm trying to think of like when you would do that. Besides like a AAA game that you just need to render just so much stuff. Super Mario World was made for the SNES. Yeah, I know, but you know, dude, I'm running a video game history channel, okay? If you think I don't know everything about early Mario. The CRT monitor are the shaders. Oh, I don't know how I'm gonna talk about that though. I know all about the CRT monitor thing. It does look better on a CRT monitor. Even like Ocarina of Time looks like infinitely better on a CRT monitor than like the perfectly crisp polygonal hands. Fucking modern stuff. The app calls for begin GPU render pass and states that it needs each draw, bind, set, bind, etc. or actual draw commands with these states. Draw. We're not doing these. The only thing we might do is draw a circle with a GPU primitive. I don't think we're going to, because a shader can draw a circle just fine. I'm a little worried about it aliasing stuff, the circle. I don't know how that's gonna go, but we'll figure it out. Once all the render commands for the scene is complete, app calls submit GPU command buffer to send it to the GPU for processing. So yeah, our 4090 doesn't even touch the program until this stage. Oh, I should also say, if you guys ever see this SDL texture, SDL2 texture example equals yada yada. This, if you ever rendered this was GPU. You were still using your graphics card, except it was limited to 2D and it can't do like the music video decoding thing we want to do. Oh, I'm sorry, to be even more specific, SDL3 cannot decode a video. We have to use, I call it MPreg. I know that's not the name of the library. It's FFMEG, is that what that's called? There we go, FFM PEG. We're using this to decode the video. I call it MPreg. Shut up. Yeah. We're using FFM PEG to just decode the video. That's the only thing we're using it for. Everything else is SDL3. It's just, it's a limitation of our current library. Let's keep reading here. I'm missing something. If the application needs to read back data from texture or buffers, which we will, because I think that's exactly what we need, right? I'm assuming what that means is that if we decode a video, we're gonna have to, we have a lot of texture and buffers they need to read. API has an efficient way of doing this, provided that the app is willing to tolerate some latency. By some latency, I'm assuming that's like, you know, a millisecond. Listen, all right, my goal is to have 120 frames a second. Actually, ideally it's 144 frames a second, because so we can run VSync on most monitors, but that's a dream. That means we have how many frames or how many milliseconds per frame? 1000 milliseconds per second, 144 frames a second, 7 milliseconds. If I can get a music video playing at 1080p quality in the program in a reasonable amount of time, and by reasonable I mean like 2 milliseconds per frame, or sorry, 2 milliseconds per second per frame, maybe 6.9 milliseconds, perfect. True. Shooting star. When the app uses SDL download from GPU texture or download from GPU buffer, submitting the command buffer with blah 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 will return a fence handle that the app can pull or wait on in a thread. Once the fence indicates that the command buffer is done processing, it is safe to read the downloaded data. Be sure to call SDL GPU fence. So this is a problem that I've never ran into when it came to any kind of GPU rendering, which is like not syncing. What's a better word for it? When all the threads are on the same page, and it's really obviously it's bad when one thread is like doing something else it shouldn't be, or earlier than the other ones. I forget what it's called. Pacing. There's a word for it, but that's always apparently a big problem with GPU rendering. I have never ran into that before, personally. The API also has a compute support. The app calls begin GPU compute pass with a compute writable textures or buffers, a compute shader, and then it sets it needs for compute dispatches. Racing conditions. I'm pretty sure you're correct. For advanced users, this opens up powerful GPU-driven workflows. Okay. Graphics and compute pipelines require the use of shaders, which, as mentioned above, are small programs executed on the GPU. Yeah, okay, it'll talk about it. Each backend, Vulkan Metal, D3D12, Direct 3D12, requires a different shader format. When the app creates the GPU device, the app lets the device know which shader formats the app can provide. It will then select the appropriate backend depending on the available shader formats and the backends available on the platform. When creating shaders, the app must provide the correct shader format for the selected backend. If you would like to learn more about why the API works this way, yeah, it's a thin level API. There is something that they're not talking about here, which is shader language binary. There's a specific kind of language we're going to use. Nice bow. Yeah, Aphrodite. An artist made it for me once without me even asking, and it was really nice. Spurvy! Oh, you know your shit! Yeah, we're using Spurvy. Spurvy is, I don't even know if it's pronounced Spurvy. Basically, it's glorified binary where any shader can, or any backend can read the shader. That's the goal. Wasn't Aphrodite the one to make that bow? Yes. It was Aphrodite. I think it's cute. It is optimal for applications to pre-compile the shader formats they might use, but for ease of use, SDL provides a separate project, Shader Cross, for performing runtime shader cross compilation. Chat, I have a question for you because I legitimately don't know. So, we are making technically a 3D game, albeit a very lightweight 3D game. Do we want pre-compiled shader formats, or do we want runtime shader cross-compilation for a video game? I actually don't know which one we're going to use. The reason I ask is because it's a video game, which implies there's some level of runtime requirement. But on the other hand, if every note is the same but minor differences, can we not just pre-compile the shader formats and just do it that way? I actually don't know. This is an extremely quick overview that leaves out several important details. Nice documentation for still saying that. You could support both. Depends if the backend OpenGL is runtime and Vulkan is pre-compiled. I don't know, to be honest. OpenGL is runtime? I actually didn't know that. Alrighty though, one can see that GPU programming can be quite complex. If you just need simple 2D graphics, the render API is much easier to use, but still hardware accelerated. So that's what we talked about before. That's SDL2. You still have the old render API. It was limited. It had problems, but it was still hardware accelerated. Namely, aliasing, in my experience, that was the problem with the SDL2 render engine, was aliasing was pretty bad. Font took us a long time to figure out in the card game to make that look good on text. But even then, outside of the context of text, like, aliasing was an issue. The hell are we listening to? Oh, it's the cross. Okay, let's listen to Gargura. It's the cosplay covers. GPU API target is a feature set with a wide range of hardware support, ease of portability. It is designed so that the application won't have to branch itself by querying feature support. If you need cutting edge features with limited hardware support, this API is probably not for you. Nope, not us. I mean, it is for us. We're not using cutting edge features and all that shit. Here's some tips for maximizing your rendering performance. Probably obvious stuff to a lot of you, but hey, we're part learning SDL3 here. Beginning, a new render pass is relatively expensive. Use as few render passes as you can. Unless I'm mistaken, we need at least one render pass every single frame. So that's fine. It says relatively expensive. In computer terms, that means like, instead of taking 5 nanoseconds, it takes like 400 nanoseconds. So minimize the amount of state changes. For example, binding a pipeline is relatively cheap. I can probably zoom in for you guys a bit, huh? Binding a pipeline is relatively cheap, but doing it hundreds of times when you don't need to will slow down performance significantly. Perform your data uploads as early as possible in the frame. What? Perform your data uploads as early as possible in the frame. Why? I wonder what that means. Like, I understand what it's saying in that since your rendering is your very last step in the frame, you want your data uploads as early as possible to give the GPU time to do its stuff. Probably to prevent like racing issues, I guess. In OpenGL, shaders are written in GLSL and compiled at runtime. You just provide the source code and OpenGL takes care of the compilation and linking. In Vulkan, however, you must pre-compile your shaders into SPIR-V binaries before using them. Oh, we're probably going to use the SPIR-V thing for for STL3 only because I feel like it's just better for our use case. It's not that hard anyway. We'll probably just pre-compile and then just call it a day because STL3 will it's an open platform, so regardless of what platform we're on, like Apple or whatever, it'll go to Metal or whatever. So I'm assuming OpenGL would be fine as well. Do not churn resources. Creating and releasing resources is expensive. It's better to create what you need upfront and cache it. Obviously, this is like all programming though, or at least all video game programming, where you can have an incredibly smooth and beautiful video game, but at the cost of memory. Like, I bet, chat, I'm betting one day people will realize you can make a video game that uses 100 gigabytes of RAM at any given moment, and it will be the most smooth experience you could ever have. It'll be beautiful. Do not use uniform buffers for large amounts of data, more than a matrix or so. Use a storage buffer instead. So here's my question. What is the use case for a uniform buffer then? So if a single matrix is all you should put into a uniform buffer, what's the use case? What is the difference? A storage buffer is like you're loading a 3D model into the GPU to render, I don't know. I think a uniform buffer is meant to be like just a small piece of data that is very efficient to toss around. But if you have like a huge amount of data in it, it just takes forever to load. I mean, it's pretty obvious, I guess, from reading it. I can't get more specific than that. I don't really know, to be honest. Use cycling correctly. There is a detailed explanation of cycling further below. Use culling techniques to minimize pixel writes. The less writing the GPU has to do, the better. Culling can be a very advanced topic, but even a simple culling technique can improve performance significantly. I see this a lot in Unity games. If you guys have ever played like Unity games by like indie developers, you see a lot of like lag and performance issues. Almost always it's a culling issue in my experience. It's Unity just lets you press one button and you can cull everything you're not seeing on the viewport. So if you're looking forward as the character, the GPU will only render things you're seeing, and that's like basic culling, right? But I feel like a lot of the times that's not enough, because like if you're looking at a building, like if you have like a cityscape and you are Spider-Man and you're looking at a building, like I feel like that basic culling of only rendering things you see is actually kind of a problem. Right? Is that a good example? That's not a good example, because you'll just see the building and that's all you're gonna render. Imagine you're standing on top of a building and you're looking at the cityscape. You're gonna lag because you're only culling what you don't see, but you see the entire cityscape. A more mature 3D game engine will like make buildings have less and less detail the further away it gets from the character, something that Unity does not do by default. I never used Unity, but I can't imagine it would do that by default. In general, the golden rule of performance, doing things is more expensive than not doing things. Don't touch the driver. Okay, Jesus. Wow. Do not touch the driver. Okay. When are you adding more advanced features like ray tracing or mesh shaders? We do not have immediate plans for more bleeding edge features, but we certainly might in the future. These features prove worthwhile. It's reasonable to implement across several platforms, underlying APIs. I have no personal interest in ray tracing. If it is a precompiled version of the shader binaries for your cards, or if you haven't disabled precompiled shaders in the config, use those precompiled shaders. Otherwise, use runtime compilation. Oh, okay. Well, I mean, I'm not opposed to either. Max distance view and level of detail helps a lot in game. Yep, I agree completely. And a lot of indie developers don't take that effort. Why is my shader not working? A common oversight when using shaders is not properly laying out the shader resources or registers correctly. The GPU API is very strict with how it wants resources to be laid out, and it's difficult for the API to automatically validate shaders to see if they have a compatible layout. See the documentation for create shader. Okay, so when we make shaders, we have to do them in a super specific order, which in this case would be vertex shader is that, oh, sample textures, storage buffers, samplers with indices corresponding to the sample textures, uniform buffers. For pixel shaders, it's a different order. Actually, it looks the exact same. For MSL Metal Live, use the following order: texture, sample, buffer, so on, stage in. Interesting. Those indie devs are probably not aware of how to optimize their game. Well, we're gonna be different. The hell am I listening to? Oh, that one. That has 17 million views, believe it or not. This is a Breaking Dimensions. It's classic. System requirements. Vulkan, Nintendo Switch, Linux, Windows, Android, yada yada. Damn. Direct 3D D12, Xboxes, Windows 10 and up. Metal is Mac OS, iOS. Uniform data, a note on cycling. Okay, here's what we're gonna do. I had a late start. Actually, I had a really late start today because I was trying to get the Gary set up. Okay, hi. Here's the plan. Tomorrow, we're actually going to implement. Did I just? Fuck, I messed that up. We're gonna fix this. This is a disaster right now because it's a problem. Basically, I have this project, but I think I'm fucking up actually importing the library correctly. So we're gonna do this tomorrow. I know we had a really short stream, but it's already getting late for me. And are you gonna make a console port? No, but because we're using SDL3 and a very generic shader setup, meaning any shader could use it, it would be easy to pay somebody to port it. I mean, we could do it, I guess. SDL3 is fully capable of doing any sort of console ports or iOS ports. We have touchscreen capabilities. Anyway, that's gonna be it for today. We are gonna stream tomorrow. We're gonna stream tomorrow, but we'll talk about it then, all right? So have a good night, have a good evening. I'll see you guys later. Goodbye. I